My name is Hichi-san, KIG 170037.
My name is Ng Eng Yu, KIG 1700124.
And I am Chia Yan Xiang, KIG 170026.
In this video, I'm going to talk about the difference between AC motor and brushless DC motor and how they are working.
I'm going to talk about the application and how to control the AC motor and brushless DC motor.
Lastly, I will discuss about the comparison between AC motors and DC motors.
Hi everyone, I am going to talk about the AC motor and DC motor. An AC motor is an electric motor driven by an alternating current. It consists of two basic parts, an outer stator and an inside rotor. The stator is supplied with alternating current to produce a rotating magnetic field, while the rotor is attached to the output shaft to produce a second rotating magnetic field. There are two types of AC motor, which are induction motors and synchronous motors. The induction motors always depends on a small difference in speed between the stator rotating magnetic field and the rotor shaft speed to induce rotor current to the rotor AC winding. As a result, it cannot produce torque near synchronous speed where induction is irrelevant to AC. In contrast, the synchronous motor is independent on slip induction for operation. The synchronous motor produces its rate torque at exactly synchronous speed. Brushless DC motor, also known as a synchronous DC motor, is powered by direct current electricity. The construction of a brushless motor system is typically similar to a permanent magnet synchronous motor, but also can be an induction motor. Basically, a brushless DC motor can be constructed in two ways: by pressing the rotor outside the core and the winding in the core to reduce the rate of heat dissipation from the motor and operates at low current, while another one is pressing the winding outside the core to dissipate more heat and causing an increase in its torque. In AC motor, both the stator and the rotor produce rotating magnetic fields. In the windings of the stator, this rotating field is provided inherently by the sinusoidal nature of alternating current. In the rotor, the magnetic field is created by permanent magnets. As the coils are energized, the magnetic field produced between them induces an electric current in the rotor. This current produces its own magnetic field and that try to oppose the things that cause it. The interaction between the two fields causes the rotor to turn. As the magnetic field alternates between the coils, it efficiently rotates around the motor. The rotating magnetic fields make the rotor spin in the same direction and at almost the same speed. A brushless DC motor has permanent magnets on the outside of its structure, with a spinning armature on the inside. The permanent magnets, which are stationary on the outside, are called the stator. The armature, which rotates and contains an electromagnet, is called the rotor. In a brushless DC motor, the rotor spins 180 degrees when an electric current is run to the armature. To go any further, the poles of electromagnet must flip. As the rotor spins, make contact with the stator, flipping the magnetic field and allowing the rotor to spin a full 330 degrees. A brushless DC motor is essentially flipped inside out, eliminating the need for brush to feed the electromagnetic field. In brushless DC motor, the permanent magnets are on the rotor, and the electromagnets are on the stator. A computer then charges the electromagnet in the stator to rotate the rotor a full 360 degrees.
Hi everyone, I'm going to introduce the application of AC motor and brushless DC motor and also how to control the AC motor and brushless DC motor. Here is some application in AC motor and brushless DC motor. As figure show, in household application, there is AC fan and air conditioner rotary compressor fan used as AC motor to function. In industry, AC motor used in fixed crank and conveyor belt. For the electric bicycle, leaf blower, and servo motor that automotive manufacturing and repairing the car is using the brushless DC motor to operate. So, how to control the brushless DC motor? While brushless DC motor, BLDC motor, are mechanically relatively simple, they do require sophisticated control electronic and regulated power supply. The designer is faced with the challenge of dealing with a three-phase high power system that demands precise control to run efficiently. The figures show a typical arrangement for driving a BLDC motor with Hall effect sensors. This system shows the three coils of the motor arranged in a Y formation, a microcontroller, an insulated gate bipolar transistor, IGBT driver, and a three-phase inverter comprising 6 insulated gate bipolar transistor. The output from the microcontroller that minor by the IGBT driver comprise pulse width modulated signal that determine the average voltage and average current to the coil and hence motor speed and torque. The motor uses 3 Hall effect sensor A, B, and C to indicate rotor position. The rotor itself uses 2 pairs of permanent magnet to generate the magnetic flux. The system employs a 6-step commutation sequence for each electrical revolution. For the back EMF measurement is also used control sensorless brushless DC motor. A voltage applied across a motor winding forces the motor rotor to turn. The movement of the rotor through the motor magnetic field. However, it analogs to the behavior of a generator, and consequently, the motor not only receives and applies voltage, but also generates its own voltage. This voltage is referred to as back electromotive force or back EMF, and it is proportional to the motor rotational speed. Back EMF can be used to determine a motor rotor speed and position, but no sensors are required. As for the AC motor, mostly we will use the AC controller to control the AC motor. An AC controller, sometimes referred to as a driver, is known as the device that controls the speed of the AC motor. An AC controller can also be referred to as a variable frequency drive, adjustable state drive, frequency converter, and etc. The AC motor receives power, which is ultimately converted by the AC controller into an adjustable frequency. This adjustable output allows the motor speed to be precisely controlled. That's all. So I will pass to the Jianxiang. Okay.
I will talk about the comparison among AC motors to DC motors. And I will point out 11 points in this comparison. The first one is AC motors are powered from alternating current, while DC motors are powered from direct current. Second point, the DC quantity that you supply to a brush DC motor gets converted into alternating quantity in the armature circuitry by the help of the commutator and brush assembly. In case of a brushless DC motor, this takes place in the inherent driving circuits. The commutation is periodically reversal of the current direction between the rotor armature and the external circuit. The third point, in an AC motor, the inversion of quantities is not required. The fourth point, DC motors are usually seen in application where the motor speeds needs to be externally controlled, while AC motors work best in the application where power performance is sought for extended periods of time. Next, all DC motors are single phase, while AC motor can be single phase or three phase. The sixth point is, in DC motors, the armature rotates while the magnetic field doesn't rotate. While in AC motors, the armature does not rotate and the magnetic field continuously rotates. And the seventh point is, DC electrical motors have many moving parts that are expensive to replace, and DC electric motors repair is usually more expensive than using a new AC electric motor with an electronic controller. The eighth point is, AC motor do not use brushes, while DC motor use brushes. Furthermore, AC motors can withstand wear and tear and have a longer lifespan. The next point is, DC and AC motors have differing means of speed control, while DC motors are controlled by varying the armature winding current. AC motors simply vary the frequency. The last point is, DC motors are self-starting and require no external help, whereas AC motors require effective starting equipment to start operation. That's all for me. Thank you.